guys, welcome back. We're going to do another Algebra 2 topic and we're going to cover logarithms or log. So log, according to this definition, indicates the power or the exponent to which a base number must be raised to produce a specific value. So here's what I want you to turn your attention to. So in this case, x, log of x represents our base. X is our base. Y is our answer, and z is our exponent. And so if we take this definition into consideration, it makes more sense. X our base, z our exponent, and then y our answer. So basically what it's saying is that through log we can figure out the exponent that we raise a base to in order to give us an answer. So let's say I have a base of 5 raised to x, and it gives me 125. Even if you might know the answer mentally, this is how you would write it in logarithm form. So log, what's our base? Our base is 5. Log 5, then our answer is 125, and it's equal to x. And if you want to find what the actual log is, you would only input this in the calculator, and whatever you get would be x. Now vice versa, it would work the same. If you only had, let's do a different one. Let's say you had log 2, base of 2, then your answer was, let's say your answer was 8, is equal to your exponent, which let's say is x. So how do you rewrite this? Well, this is saying your base of 2 raised to whatever x is going to give you an answer of 8. So as you can see, log and exponential form can be switched interchangeably if you know where each variable or number or value goes. Now I want to show you how you can use log in a type of equation or question that's asking you to solve for x. So here we have 29 times 10 to the power of 5x is equal to 88. So we want to isolate the x variable. So the first thing is we can do the inverse of multiplication, where we divide by 29 on both sides. And now we're going to be left with 10 to the power of 5x is equal to 3.03448. You always want to round at the end. Don't round too early. So now, this is basically what we did up here. We are trying to find what exponent we have to raise the base of 10 to in order to give us this 3 point blah. So I can rewrite this as log. My base of 10 will give me 3.03448. Should equal 5x, right? And now the answer that I get when I put this in the calculator is going to be 0.482085 is equal to 5x. And now I just solve for x. So I divide by 5 on both sides in order to isolate the x variable. And now I'm left with x is equal to around 0.10. Because it's asking to round it to the nearest hundredth. This is our tenths and this is our hundredths. Now let's read this practice problem. Brooklyn invested $25,000 in an account paying an interest rate of 6.8% compounded monthly. Assuming no deposits or withdrawals are made, how long would it take to the nearest year for the value of the account to reach $65,500? So let's see. What are we looking for? We're given our principal value, which is $25,000. We know that our rate is 6.8%, and if we divide it by 100, we would get 0.068. Now that's our rate, because now it's a decimal, and it's compounded monthly, so our value of n is going to be 12, because it's monthly, and then it's asking us to find t in years. That we don't know, but it gives us what our final amount should be. So basically, it's saying that A is $65,500. So now we just input this into our equation. So 25,000, that's always what we start with, our principal value. Now, again, since we're doing compound interest formula, we have to do 1 plus our rate in decimal form, which is 0.068, over the number of times we're compounding, which is 12 because it's monthly, and then 12t. We're putting t because it's asking us to find how long it would take to the nearest year, so we don't know what the years is. Then we set it to 65,500. And now we just solve algebraically. So our first step would be to either simplify what's in here or divide by 25,000. Either one would work. So we divide by 25,000 on both sides. And now we're left with this. I'll just simplify it right away. So now we're going to have 1.00567 raised to 12t is equal to 2.6. That's what 65,500 divided by 25,000 is. So now we basically have the same situation that we did last time in the previous question. We can do log again because we're trying to find the exponent that we raised this base to in order to give us 2.6. So we would write log of 1.00567, and then our answer has to be 2.6, and then it has to be equal to 12t, which is our exponent. And then we put in the calculator, and now we have 169.097 equals to 12t. And now we just divide 12 on both sides to isolate the t, and we get 14 years. T equals 14. So our answer is 14 years. It would take 14 years for the value of the accounts to reach 65,500.